Okay, so section 2.4 is the last section of chapter 2 that we look at. And up until this point, all of the work that we've done in set theory has been mostly, I guess, what I would describe as abstract, mostly in the sense that we haven't looked at applications of any of this material yet. Now, I think I mentioned at the beginning of this course that a lot of the material we look at, we don't really dig that deep into applications because this is more of an overview kind of course, more of a, I described it as an appreciation course, just kind of looking at some interesting math topics. But section 2.4 actually does go into an application of the set theory and the work with Venn diagrams that we've done up until this point. And it comes down to analyzing surveys in this section. So you're all familiar with what a survey is, I'm sure. Researchers often use surveys, as I say right here, to collect data on a particular population based on whatever it is they're researching. Surveys typically consist of, lists of questions, and different individuals within the population may answer some of those questions the same way and other questions in a different way. And what we want to do here is look at how to draw conclusions based on information that might have been gathered from a survey. So, or if not a survey, some other collection of data. So here's our first example. Giddy is a fan of music, or the music of Paul Simon and Art Garfunkel. In her collection of 25 CDs, which I don't even know if people use CDs anymore, she has the following. Now this is the information that we have to work with, and A through D are the questions that we're going to try and answer based on that information. So 5 of the CDs have both Simon and Garfunkel singing. 7 of the CDs have Simon singing. 8 of the CDs have Garfunkel singing, and 15 of them are neither Simon nor Garfunkel singing. And we have all of these questions that we want to answer. Now, the way that we're going to analyze this is we're going to create a Venn diagram. I'm going to do that off to the side here. This Venn diagram, however, will involve no shading. It's going to involve some numbering that we're going to use. Okay, so we have our universe here, and then I have these two sets. Okay, set S and set G. Okay, so S is going to correspond to the CDs on which Simon or Paul Simon is singing. The G here, the set G, is going to be indicating the set of CDs on which Garfunkel sings. Now notice that I didn't use the word only. The set here, set S, consists of CDs on which Paul Simon sings, whether he sings alone or sings with Art Garfunkel. Similar for G, this set consists of all the CDs on which Garfunkel sings, whether alone or with Paul Simon. This overlapping region, therefore, would represent the CDs on which both singers are singing. What does this region outside of the two circles represent? Well, that would be the complement of the union of these two sets, if we want to use the terminology we've been using up until this point. It would represent the CDs on which neither vocalist sing. So those would be like instrumental albums. Okay, so how can we use the information that's given to us here to determine how many CDs belong in each of these 4 regions? And notice that there's 4. 1, 2, 3, 4. If I can insert numbers into those, I can answer the questions that were given. So notice it says there are 5 CDs on which both Simon and Garfunkel sing. Can we determine which region of these 4 correspond to that? Well, it's the overlapping region. This is where those 5 CDs live. Okay, and that's fairly easy to see. That's where both singers are present on the album. 7 CDs on which Simon sings. That does not mean that we're putting a 7 here, because again, this region right here, this region that I'm kind of pointing at, is only the region consisting of CDs on which Simon sings alone. But remember, this is just CDs on which he appears, whether he's alone or paired up with Art Garfunkel. So what that tells me is that the total of the regions that are in this circle S has to come out to 7. So that means this region right here is 7 minus the 5 we've already accounted for in the overlap, giving us 2 CDs on which Simon sings alone. So now I have 2 of my 4 regions accounted for. This is similar. There are 8 CDs on which Garfunkel sings, whether alone or together with Paul Simon. So this circle here, G, in total should come out to 8. But this region right here should be 8 minus the 5 that were already accounted for here, giving me 3 albums in total. Okay? Finally, we're told that there are 15 albums on which neither Simon nor Garfunkel sings. Well, that means that if neither singer is present on the album, that would put the 15 outside of both circles, out in this region. Okay? Now that we've numbered everything off, I have the ability to answer the questions. How many of her CDs feature only Paul Simon? Well, remember, that's this region that's outside of the overlapping region, but still inside of the circle S. There's 2 there. So the answer to part A is 2. How many of her CDs feature only Art Garfunkel? Well, that's everything outside of the overlapping region, but still inside the circle G. That would be 3 of her CDs. How many of her CDs feature at least one of these 2 artists? So that's 3 regions that we need to consider. Either only Simon, only Garfunkel, or both Simon and Garfunkel, since in all 3 of those cases we have at least one singer present. That would be 2 plus 5 plus 3, which is 10. Okay? And then finally, how many CDs feature at most one of these 2 artists? Meaning either 0 artists or 1 artist, but no more than 1. Well, that would include the instrumental albums, since 0 artists is the same is at most 1 artist, because that means 1 or less. Or either of these 2 cases where we have just Simon or just Garfunkel singing. So that's 15 plus 3 plus 2, which is 20. Okay? And you can see the Venn diagram sort of gave us the information that we needed in order to answer this question. Now, this case was fairly straightforward, not too difficult, and the reason for that is because we only had 2 sets within the universe that we had to consider, giving us a total of only 4 regions that needed numbering. This gets considerably more complicated when we go from 2 to 3 sets, as we do in this next example. So let's take a look at this one next. A middle school counselor surveyed students to determine which of 3 movies the students had seen. And the movies are Despicable Me, Coco, and The Boss Baby. We have this list of information here telling us kind of the breakdown of different groupings of these things. So 34 had seen Despicable Me, 29 had seen Coco, 26 had seen The Boss Baby, etc., etc. You can read that. I don't need to read all that to you. In this case, we are going to have a total of 3 sets that we need to consider. 1 for each of these 3 movies. So there's going to be 1 up here. I'll put 1 right here and 1 right here. I'm going to call this D for Despicable Me, C for Coco, and B for Boss Baby. Okay? Notice there's a lot more regions to consider. We have, let me call this U for the universe. I have 1, 2, 3, 4, 5, 6, 7, 8 different regions that I need to number off. And I'm not going to just use these numbers directly because a lot of these numbers are actually representative of a combination of regions, not just one isolated region. So we need to be really, really careful with that. Let's actually start from the bottom. It's easiest to start from the bottom, and you're going to see why in a moment. 5 had seen none of the films. What part of this diagram would represent that? Well, again, the set C, for example, total of the regions that are contained in C should be the total number of students that have seen Coco. This represents the number of students that have seen Coco, and similar for the other two movies. Where do we put the students who've seen none of the films? Well, that would have to be outside of all 3 circles. That means all 5 of the students who hadn't seen any of the films belong out there, outside of the circles, but still within the universal set U. Next up, 4. How many students had seen all 3 films? Well, only one region represents students who have seen all 3 films, and that would be the overlap of all 3 circles, which appears here. It's easiest to start with those because those 2 values in the in this list are the only ones that correspond to exactly one region in this Venn diagram. All of these other numbers correspond to combinations of regions here. So still working from the bottom up. 10 had seen Coco and the Boss Baby. What region represents the students who had seen both of those movies? Well, Coco is the circle C, Boss Baby is the circle B, and so what that means is that the 10 students who had seen both movies belong in this overlapping region between circles C and B. But that overlapping region is actually made up of 2 smaller regions. This region here, which we already found a value for, and this region here, which we don't have a value for. I know, however, that this number has to correspond to the 10 students that are in the total minus the 4 students who are in the overlapping region for all 3 circles. So that's 10 minus 4, which equals 6. Now, what does that 6 represent? Well, because that 6 is in this particular region, this represents the set of all students who have seen both Coco and Boss Baby, but have not seen Despicable Me. Okay, so these 2 regions total up to 10, and that's because in both regions we're accounting for students who had seen both of these movies, whether or not they have seen Despicable Me. We could do something similar for these other regions as well. So 12 had seen Despicable Me and the Boss Baby. Where is Despicable Me and the Boss Baby? That overlaps here in this kind of football shape. That's also split up into 2 regions. 4 plus this missing value should equal 12. So that gives me 12 minus 4, which is equal to 8. I would need to put an 8 in there. Okay? Continue working our way from the bottom up. 16 had seen Despicable Me and Coco. That's this overlapping region between circles D and C. And again, 2 regions where we know the value of one of them to begin with. 16 students should be the total. If I subtract the 4 in the overlapping region, that should give me 12 in that region right there. 12 students who've seen Despicable Me and Coco but have not seen Boss Baby. All right? Now we're in the last, or really the first 3 items, but working our way from the bottom up is what allowed us to get to this point. So 26 had seen the Boss Baby. What does that account for? Well, Boss Baby is this entire circle right here, the circle B. So that 26 students actually represents the sum of 4 regions, 6 plus 4 plus 8 plus whatever this unknown region is here. That's the next goal, is to fill that in. So to do that, take the 26 students that we should have in the total, subtract 8 minus 4 minus 6. Those are the other 3 regions. What does that come out to? Well, I can think of this way. This totals to 18. If I subtract 18 from 26, that's 8. Okay, so that means there's 8 students in this region here. Excuse me. I'm going to do something similar with these last 2 regions here. 29 students had seen Coco. That's the circle C. So I take 29, which is the total, and subtract the 3 regions that we know, 12 minus 4 minus 6. What is that? Well, again, 4 plus 6 is 10, plus 12, that's 22. 29 minus 22 is 7. So there should be 7 students in that region. All right, one last region to fill in. How many students belong in this region up here, the set of students who've only seen Despicable Me but none of the other two movies. Well, the total for the circle D should be 34. That's the set of all students who have seen Despicable Me. So I take the 34, which is my total, and subtract away these other regions. 12, 4, 8. Okay? So let's see. 34 minus 4 is 30. 12 and 8 makes 20. So if I subtract 20 from 30, that should be 10. Okay? And now if you notice, every single region has a value assigned to it. And having found those, I can answer all three questions. So for example, part A, how many students had seen the Boss Baby only? Well, remember, that's Boss Baby is the circle B, and the students who had seen only that movie should be the students who are inside circle B, but outside of circles C and D. That would be this 8 right here. And answer that question. How many students had seen exactly 2 of the films? Okay, so that one, if students have seen 2 of the films, then they should be in an overlapping region between 2 circles. And 4 of these regions, 1, 2, 3, 4, make up the overlap of circles. However, we don't need all 4 of them. It says how many students had seen exactly 2 films, meaning these 4 students who had seen all 3 films don't count. We don't want to count them. Only the 12, the 8, and the 6 correspond to the students who've seen exactly 2 movies. So that's 12 plus 8 plus 6, which is 26. There's 26 there. Okay? The final question says, how many students were surveyed? Well, each of these regions that I've assigned a number to are mutually exclusive, meaning there's no overlap between this 5 here and this 7 here. And there's no overlap between this 7 here and this 12 here. And not only that, I've assigned a number to every single region. So if I can total all of this up, I should end up with the total number of students that were surveyed. Notice you do not want to total these numbers up, because many of these numbers overlap with other categories that have been listed here. But we've now separated all of these categories out. So what are the values that we're looking at here? 10 plus 12 plus 8 plus 4. So 10, 12, 8, 4 plus 7 plus 6 plus 8 plus 5. I want to make sure I didn't miss anything. There should be 8 total here. All right. Wrote that down there. So we're going to total things up. That's 10 plus 11 is 21, 27, 35, 40. Carry the 4, 60 students total. Okay, so we've ended up with a total amount of 60 students here. And again, it's more complicated when you're dealing with 3 categories or 3 sets instead of 2. But the approach is very similar. And just to recap on what we did, we very intentionally started from the bottom up, because these last 2 items here corresponded to individual regions as opposed to combinations of regions. That allowed us to fill in all the other blanks. We have a couple more examples to look at in this section, and we're going to do those in the next video.